Hi everyone. In this video we are going to discuss about the second theorem, which says sides opposite to equal angles of a triangle are equal. Let's suppose we have a triangle like this. As in the diagram you can see triangle ABC, and it has two angles equal, which are angle ABC and angle ACB. I have denoted that with an alpha. So those two angles are equal angles. You can say angle B and angle C, they are equal angles, and we have to prove that the sides opposite to these equal angles. So what are those sides going to be? Well, they will be the side AB and AC. So we have to prove that AB is equal to AC, right? Now for us to be able to prove this theorem, we have to draw an angle bisector for the angle A. So let me first draw the angle bisector. Let's assume that AD is the bisector of the angle A. So AD will divide the angle A into two equal halves. Each of them will be A over 2. That means angle BAD and angle CAD, they both will be equal to A over 2. And now if we look at these two small triangles, triangle ADB and triangle ADC, if we look at these two small triangles, you will notice for triangle ADB, we can say that angle ADB plus alpha plus A over 2, that's the sum of the three angles of the triangle, that will be equal to 180 degree. And similarly for triangle ADC, we can say that angle ADC plus alpha plus A over 2, that is the sum of the three angles of that triangle, which is the right side triangle, that is also equal to 180 degree. And from here we can then say that angle ADB will be equal to 180 degree minus alpha minus A over 2, and similarly angle ADC will also be 180 degree minus alpha minus A over 2. So if you think about the angle ADB and angle ADC, they are actually equal in measure, they are equal angles. And I have denoted that with a beta, assuming that each of those angles is equal to beta. You can say beta degree or beta radian, either way it's fine. I'm just taking it as beta, right? And also between these two triangles, as you can see that angle BAD and angle CAD, they are also equal because each of them is half of A. So now if you think about it, between these two triangles we have two pairs of angles that are equal, and we also have a common side between them. What is the common side? Well, that is the side AD. So triangle ABD also has a side AD, and triangle ADC also has a side AD. That means they have equal sides. So that one side, which is the common side, that's actually equal between the two triangles, right? So now we can use the ASA criteria of congruence for triangles. Here we have two pairs of angles equal between the two smaller triangles, and also there is a common side which is an equal side between the two triangles. So we can use the ASA criteria for congruence, and based on that we can say that these two triangles are actually congruent triangles. Now in triangle ABD, side AB is actually opposite to the angle ADB, and similarly in triangle ADC, side AC is opposite to the angle ADC, and we have already proved that angle ADB and angle ADC, they are actually equal, and we have assumed that to be beta, which is actually 180 degree minus alpha minus A over 2. So because those two angles are equal, using the CPCT property of congruence that says that corresponding parts of congruent triangles are equal, we can say that AB and AC, they are being the corresponding sides between the two congruent triangles, they will be equal. And that's exactly what we needed to prove here, right? For this theorem, we needed to prove that AB is equal to AC, and we have been able to prove that yes, in fact, AB is equal to AC. The main concept here is that we have to prove those two triangles are congruent, and then we have to show that AB and AC, they are actually corresponding sides of those two congruent triangles. And using the CPCT property, we can say that the corresponding parts of congruent triangles are equal, so AB must be equal to AC. So our main theorem has been proved. And here I'm going to show you a couple more things. Now let's look at BD and DC. If you think about it, they are also corresponding sides between the two congruent triangles. BD and DC, they are corresponding sides, so they will also be equal. And also if you think about the angles ADB and angle ADC, you will realize that each of those angles being equal, they will be equal to 90 degree, because the sum of those two angles will be a straight angle. That means beta plus beta will be equal to 180 degree. That means beta will be equal to 90 degree. So let me make a note of that also. So we see that BD equals DC, and also the angle beta is equal to 90 degree. That means AD is a perpendicular bisector of BC. Can we say it like that? Because you see AD is dividing BC into two equal parts, and also AD is perpendicular to BC, because angle ADB or angle ADC, each one of them is equal to 90 degree. So we can say that AD is nothing but a perpendicular bisector of the opposite side BC. Now AB and BC being equal, this means that this triangle is an isosceles triangle. So for an isosceles triangle, if we draw a perpendicular from the vertex that is contained between the two equal sides, if we drop a perpendicular from that vertex onto the opposite side, that perpendicular actually divides the opposite side. Or in other words, you can say that if we draw an angle bisector of the angle that is contained between the two equal sides, if we draw an angle bisector, then it will become a perpendicular bisector of the opposite side, and all of this is applicable for an isosceles triangle. So because we have been able to prove that AB is equal to AC, this is an isosceles triangle, and AD seems to be a perpendicular bisector of the opposite side, and AD itself is a bisector of the angle A. So let's make a few notes here. So here I have noted that triangle ABC is an isosceles triangle where AB is equal to AC, and then AD is the bisector of the angle A, which is the angle BAC, and AD also bisects the opposite side BC. It just happens to bisect it. As soon as we draw AD as a bisector of angle A, then we are able to prove that for this isosceles triangle, AD also bisects the opposite side BC, and also we are able to prove that AD is perpendicular to BC. I hope everything made sense. Thank you for watching. See you in the next video.